Hello, my name is Dilip Kikla. I'm a global principal sales specialist at AWS for Analytics, focused on Amazon Redshift. Today, we will be talking about modernizing your data warehouse with Redshift serverless, analyzing all your data across data stores at scale at the best price performance. Joining me today is Bal Herur, principal consultant at Muras, who will be talking about their Google BigQuery to Redshift migration offering. I will kick it off and talk about the challenges you, our customers, are sharing with us and how Redshift serverless can address them. We will then talk about how you can start your migration journey with AWS. We will then move to an AWS SCT migration demo and conclude with Mactaurus sharing their migration case study and a demo. With that, let us begin. In the modern world, only the most informed succeeds. Those who have direct access to their data make better, more informed decisions, respond faster to the unexpected, and uncover new opportunities. Analytics requirements are now coming in all forms from all corners of the enterprise. And the data sets for them have increased from terabytes to petabytes. And now we see customers with even exabytes of data. This data is also stored in various data sources, in relational and non-relational databases, in data lakes within the data warehouse. Each department and each region is creating their own data. How do customers harness all of this data seamlessly? And how do they make sure performance is not degraded when data grows so quickly? How do they perform complex SQL-based analytics at scale? And how do they scale capacity without impacting price performance? These are the challenges on our customers' minds today. In addition to these, data users within organizations are growing like never before. Everyone wants fully managed, self-service, and zero-touch analytical systems to leverage data as part of their day-to-day job to derive faster insights. At AWS, we call such an analytics system the modern data architecture. It enables organizations to store any amount of data in open formats, break down disconnected data silos, empower people to run analytics or machine learning using their preferred tool or technique, and manage who has access to specific pieces of data with proper security and data governance controls. A modern data architecture provides data at any scale, purpose-built data stores, unified data access, security, and governance, built-in AI and ML. Now the question is, how do you get to this modern data architecture without worrying about any infrastructure and get insights from your data in seconds? AWS can help. AWS now has the most serverless options for data analytics in the cloud. For data warehousing, we have Redshift serverless. For big data processing, we have EMR serverless. For streaming and real-time analytics, we have MSK serverless and Kinesis data streams on demand. For interactive analytics, we have Athena, which is serverless by nature and supports all data lake security. For data integration, ETL, and catalog, we have Glue, which has been supporting serverless Spark since 2017. For data lake setup, management, and governance, we launched Lake Formation, which is also serverless by nature. And for data visualization, we have QuickSights. For almost every type of analytics need, we have a serverless option to make it easy for our customers to do what they do best, focus on their application while we handle the rest. Now that you have seen an overview of the AWS Analytics serverless options, let us dive deeper into Amazon Redshift for data warehousing. Customers are using Amazon Redshift serverless to easily run and scale analytics without having to manage data warehouse infrastructure. We want you to focus on insights while we take care of infrastructure needs for you. Amazon Redshift automatically and intelligently provisions capacity for your most unpredictable and demanding workloads, and you pay only for what you use. Today, tens of thousands of customers use Redshift every day to power their analytics workloads and get insights from the data, which is sitting across different data sources. Redshift helps them analyze petabytes of data in a matter of minutes. Talking about NASDAQ, a major stock exchange in the US, they are ingesting tens of billions of records of market data in the S3 data lake. Time to market is key for their analysts to receive real-time insights on their stock market data. NASDAQ is running queries using Redshift to join data that sits in the local Redshift data warehouse and in the S3 data lake to get real-time insights. Rail Delivery Group, or RDG, is a user of Redshift Serverless. RDG runs Britain's railway, and the business users wanted rapid and self-service access to the data without having to think about managing data warehouse and capacity. Hence, they chose Amazon Redshift Serverless and benefited from its simplicity, ease of use, scalability, and lower costs. Amazon Redshift is the most widely used and affordable cloud data warehouse. We have been investing and innovating along all of these areas to meet the customers' challenges and address your modern needs. Redshift helps you analyze all your data, your log files, your transactional data, your clickstream data, semi-structured data, or nested data without movement or transformation. Redshift is the most affordable cloud data warehouse that delivers up to 3x better price performance relative to competition. Redshift requires zero administration and reliably delivers insights from your data in seconds in a more secure way. Now with Redshift Serverless, we take it to the next level. With Redshift Serverless, you don't have to worry about data management. It takes a few seconds to get started with data warehousing. You would experience consistently high performance, even as your system scales up and down automatically. When your data warehouse is idle, you pay nothing. You can even set your own spend limits so that the system doesn't scale beyond what you can pay for. And you don't have to change anything to migrate from an existing Redshift cluster. Your applications can stay the same. There are tons of use cases from the thousands of customers using Redshift Serverless. Self-service analytics is a broad category, and serverless gets you to your destination fast. As it takes seconds to get started, data scientists, developers, line of business analysts can easily create machine learning workloads in SQL, can set up reporting and dashboarding, or conduct real-time analytics. In a way, we are democratizing data warehousing. The second class of use cases we need to address are constant predictable, unpredictable workloads or spiky workloads, or even situations where customers do have a predictable processing window. We are seeing many of our customers going serverless across the data stack. And with Redshift Serverless, we can bring data warehousing into that stack. We have an amazing offer for you, and I encourage everyone to try Redshift Serverless because it takes very little time and effort with high returns. You also get $300 credit to experiment with Redshift Serverless. Now that you are all excited about Redshift Serverless, let us talk about how to migrate from your current environment to Redshift. Customers find that the first step for migration always is the most challenging. This is because we find that some organizations get paralyzed if they can't figure out how to move every last workload. Our suggestion is there is no need to boil the ocean. For many of you, an iterative approach would be the right one, and we encourage you to take that approach. We often work with organizations to do a portfolio analysis, to assess each application and then build a plan for which application to move short term, medium term, and last. This helps organizations get to the benefits of the cloud for many of their applications quicker, and it really helps them inform how to move the rest. As we work with you to design your scalable, future proof architecture, we ensure you'll have an integrated platform with a centralized governance and security model, minimal data movement, avoiding copying of the data, and avoiding vendor lock ins are built into the design. Through this platform, you'll be able to democratize your data securely amongst your organization to gain a competitive advantage. All throughout the migration journey, AWS is your partner in carrying out the migration, ensuring migration best practices are followed, your team is developing the required skills, you're leveraging the right programming tools, and guiding you along the way. For each of the phases of migration, we have programs in place to save you time and money. The first is analyze and plan. Here you perform data discovery and planning, building a migration business case and creating a migration plan. Through our data driven everything program, we will bring your business and technology stakeholders together, leveraging a use case driven framework, developing a roadmap of priority projects. The Design Lab provides you guidance on real world architectural patterns and anti patterns, as well as strategies for building effectively. Second step is workshop and pilot. In this step, we will help you run proof of value and proof of concept to demonstrate the functionalities and performance you get with Redshift. Leveraging the Build Lab program, an engagement between you and the AWS service experts accelerates the development of a prototype to solve a specific business problem faced by you. Third step is workload migrations. The Migration Accelerator program packages best practices, expertise, tooling, and financial incentives to make cloud adoption easier, allowing customers to gain cloud benefits sooner. Throughout your migration journey, AWS Data Warehouse Solution Architects, specialist teams, professional services teams, and partners are available to help you whenever needed. Talking about partners, working with a partner can help you ensure you are using best practices and tools. This slide includes a selection, not a comprehensive list, of integration partners that have a packaged Redshift consulting offer for customers like you. We'll be hearing from one of our partners soon, Muras. Now that you know about the Redshift migration programs and options available to you, we will move to the two demonstrations. We will start with the demonstration of AWS Schema Conversion Tool, migrating database objects from Google BigQuery to Amazon Redshift.
You can use the AWS Schema Conversion tool to convert BigQuery database objects to a format compatible with Amazon Redshift. Then you can apply the converted code to your target database and migrate data. This video shows how to get started with BigQuery to Amazon Redshift migrations and covers the key steps of this process. AWS SCT uses a service account to connect to your BigQuery data warehouse. You can create a service account in the Google Cloud Management Console. But first, make sure that you turned on the BigQuery API. Then create a service account. And grant the following privileges. AWS SCT uses the BigQuery admin role to load your BigQuery metadata in the migration project. To extract data from a BigQuery data warehouse, AWS SCT uses the Google Cloud Storage bucket. To access this bucket, you grant the storage admin role to your service account. Then you create a new JSON key and use it in AWS SCT to connect to BigQuery. Check your Downloads folder to find this service account key file. Before we launch AWS SCT, let us check our source and target databases. To demonstrate data migration, we can use the line order table. This table includes some data in the source database, and it doesn't exist in the target database. We can use AWS SCT to create it. Now, we start AWS SCT and create a new project. To connect to BigQuery, we use the service account key file that we created in the Google Cloud Management Console. Then we use database credentials from AWS Secrets Manager to connect to Amazon Redshift. You can add multiple source and target databases in a single project. We create mapping rules to describe the source-target pair for our BigQuery to Amazon Redshift migration. We switch to the main view and start the schema conversion. Our source dataset includes 33 tables, 278 views, 82 procedures, and 14 functions. To assess the migration complexity, we create an assessment report for this dataset. You can see that AWS SCT converted most of the database storage objects. These objects include datasets, tables, and materialized views. Also, AWS SCT converted such database code objects as views, SQL functions, JavaScript functions, table functions, and stored procedures. However, some of the database objects require manual conversion. AWS SCT highlights these objects in blue in the conversion statistics diagram. In the Action Items tab, you can see the recommended actions for each conversion issue. For example, AWS SCT converts the BigQuery string data type to the character varying data type in Amazon Redshift. Because this data type has a shorter length, you need to make sure that you avoid data loss during migration. AWS SCT has several limitations when using BigQuery as a source. For example, AWS SCT can't convert subqueries in analytic functions, as well as geography, statistical aggregate, or some of the string functions. Find the full list of limitations in the AWS SCT user guide. We plan to address these limitations in the future releases of AWS SCT. Despite these limitations, you can use AWS SCT to automatically convert more than 80% of objects in your BigQuery datasets. Now, let us convert the dataset that includes data for migration. Here's the table that we plan to migrate. We convert the dataset. During conversion, AWS SCT automatically generates the assessment report. You can see the converted code of the line order table. AWS SCT converted string columns to character varying columns and added an action item. Now, we apply the converted code to the target database. To convert SQL statements and queries, make sure that you include them into stored procedures in your BigQuery project. AWS SCT converts all BigQuery metadata objects. For migrations from BigQuery, you can't use AWS SCT to convert external SQL scripts or additional files. Let us check our target database. After we refresh the database, you can see the new schema that includes the line order table. You can see that the line order table now exists in the Amazon Redshift database. It doesn't include any data. AWS SCT uses data extraction agents to migrate data from data warehouses to Amazon Redshift. The zip file that you downloaded to install AWS SCT includes the extraction agent installer file. Run the installer file, and then configure the data extraction agent. For source vendor, enter no because BigQuery doesn't require a JDBC driver. For target vendor, enter the path to your Amazon Redshift JDBC driver. The data extraction agent stores temporary data in the working folder. You can use the project folder as a working folder for the data extraction agent. After you configure the data extraction agent, you can review the file that includes all settings. Then, switch back to AWS SCT, choose the data migration view, and register your agent. Because our data extraction agent is running on the same computer as AWS SCT, we enter the localhost IP address as a host name. You can see that AWS SCT can connect to the data extraction agent. This completes the installation and registration of the data extraction agent. To manage the migration of large tables, you can create virtual partitions in AWS SCT. Our source table is relatively small and doesn't require partitions. However, let us show you how to create virtual partitions. We split the source table depending on the values of the third column. We use range partitioning, and create a separate partition for null values. Now, we create a local migration task. This task uses the data extraction agent to migrate data. For each task, you choose the migration mode. The available options include: extract source data and store it on a local PC where the agent runs. Extract data and upload it on an Amazon S3 bucket. Extract, upload, and copy data from your S3 bucket to Amazon Redshift. We choose this option. Also, we enter the Google Cloud Storage bucket, where the data extraction agent can store the source data. You can create this bucket in the Google Cloud Management Console. Finally, we set up the folder in our Amazon S3 bucket, where the data extraction agent can upload the data. AWS SCT creates a data migration task and a subtask for each virtual partition. You can manage data migration for each partition. Now, we start the data migration task. The data extraction agent extracts data from BigQuery. Then the agent uploads data to Amazon S3 and launches the copy command to move it to Amazon Redshift. AWS SCT migrated data from the source BigQuery table to Amazon Redshift table. Let us check this table in the target database. You can see that the data migration task completed successfully and the line order table includes data. Now, you know how to use AWS SCT to convert BigQuery projects to Amazon Redshift and migrate data. Thanks for watching this video.
You just saw the AWS SCT BigQuery migration capability. I now invite Bal from our partner organization, Mactaurus, to share their customer case study and their migration demo.
Hey, thank you, Dilip. Thank you for the introduction, and we are pretty much excited to showcase our capabilities of helping customers migrate to Redshift from BigQuery. With that, I would like to spend a few slides explaining who is Mactaurus. Mactaurus is a data analytics consulting company. Since 2008, we have been helping customers migrate their workloads to AWS. Customers work with us preliminarily for three objectives: to drive competitive advantage using machine learning and predictive analytics, save cost by reducing time to market using our accelerators, and reduce operational inefficiencies by building systems and processes using technology. With AWS, we have a very long-standing partnerships, gaining various competencies and service deliveries, helping customers automate these migrations and adopt new technologies as AWS releases them. We partner with various other ISV players in Amazon Marketplace to help customers adopt the new and latest technologies. We work with customers on various practice areas, preliminarily in data analytics and DevOps. We work with customers on various models, which involves helping customers hand in hand onshore, as well as working on retainer models to achieve these migrations. With this, I would like to introduce our customer case study for Katera and help you understand their use case and why did they migrate off BigQuery to Redshift using our BigQuery transformation services. Katera was in construction business, and their preliminary work was to build a complete start-to-end process of manufacturing timber to delivering the final building with design and architecture. They were extensively using Google BigQuery to build their data warehouse, which would give them real-time updates from all the manufacturing plants as well as all the sites where they're constructing these buildings. The cost of running all the BigQuery was not viable for the business to justify all the analytics which the customer was deriving out of those data sets. That is where they reached out to us, figuring out how we can adopt more cost-effective services on AWS. With Mactaurus and Katera, we started building on analysis of understanding what are the data sets and what are the use cases Katera is using in their environment, and built an assessment plan to assess their infrastructure, their data sets, and their use cases integrated to the end user. They were consuming about 12 terabytes of data on Google BigQuery. And the challenge was they used BigQuery to an extent where they had stored procedures, functions created to perform complex calculations. This is where our assessment framework as well as assessment tools helped us accelerate to identify which are the major risk areas in this migration. The assessment resulted in a TCO of Amazon Redshift, which would be the final cost of after migration to Redshift from BigQuery. During this journey, Katera and Mactaurus worked close together in a step-by-step process of extracting data, converting the data to Redshift, also converting a lot of their business logic, which was inherently created within Google BigQuery, to Amazon Redshift. We also identified opportunities of converting some of the stored procedures which were used as an ETL or a data pipeline inside BigQuery to AWS Glue, which further elevated their challenges of performing costly ETL operations within their data warehouse. So after this migration, Katera saved almost 60% of their operational cost over 5 years, and the accelerator reduced their total time to migration up to 75%. After that, Katera also hosts a lot of unstructured or semi-structured data on S3 and are evaluating Redshift Spectrum to integrate with the Redshift tables to perform better analysis from the raw data. Now let's see what was the philosophy and the process Macros used to help Katera to migrate out of BigQuery to Redshift, and why did it save about 75% of the migration cost. At the very beginning, once the assessment was performed, Macros had the entire understanding of the dataset and how it will translate to Redshift. Then we used our schema and data converter to analyze BigQuery tables and use our table conversion technique to quickly migrate the tables and convert the data types to Redshift compatibility. Using Glue, we could quickly extract terabytes of data out of BigQuery and transform that and ingest it in Redshift with the newly created tables, which was supporting all the data types of Redshift. This process accelerated all the migration of the tables, the data types, the data quality, while maintaining all the lineage of the data which customer was ingesting from their source systems. Next biggest problem was the stored procedures and the business logic, which was inherently used inside Google BigQuery. And this is where our partnership with BladeBridge was the most helpful for us to use this and quickly convert all the stored procedures, functions, and the business logic written within the Google BigQuery to Redshift. Let's see how it works. So we preliminarily extract all the stored procedures available in Google BigQuery, and then use a agnostic code layer to perform the transformations of the SQL stored procedures and functions to Redshift. And the way it works is we have a highly configurable converter which can take various complexities involved in the business logic and convert it to Redshift complexity within matter of days. This accelerated the complex 500 plus stored procedures conversion from Google BigQuery to Redshift up to 70% automation, where we had to just invest about 30% in converting few of the logic which was done after severe testing of each of these stored procedures, which were automatically converted by BladeBridge. In this entire process, there were multiple checkpoints to validate the outcomes of these stored procedures or the processes which were running in Google BigQuery, as well as maintaining the data quality of these conversions were tracked. Eventually, customer could get the exact outcome of what they were performing in BigQuery at 60% lower cost in Redshift, while maintaining the business continuity of using a data warehouse. Macros not only works on migrating customers out of BigQuery, but we have built similar accelerators for Oracle, MS SQL, Netezza. And we have helped several customers to migrate out of these data warehouses to Redshift and adopt more modern framework. There are several ways to engage with Macros. We work with customers to perform immersion days, where we take you through an experience of how would a migration be performed if it was your use case. We perform well-architected review of your entire infrastructure. We perform assessments to provide guidance of how exactly a migration would be performed. And then we also help you with proof of concepts to create a business use case with a proof of how much the data migration and the data adoption of your use cases will be in Redshift once migrated. Let us go through a demo of showing you how did we use AWS Glue to extract data out of BigQuery, then use AWS Redshift Loader to load that data into Redshift, and then how did we use BladeBridge to convert 500 plus stored procedures and functions to Redshift. Now let us continue with the demo to understand how we have used our accelerators along with BladeBridge converter to convert from Google BigQuery to Amazon Redshift. As previously discussed, we will be using our table scan and table conversion automation to write the tables inside Redshift. And later on, we will take you through our process of using BladeBridge code converter to convert stored procedures and functions from BigQuery to Redshift. So let's continue and see what data set we are working with. So as we can see, in our BigQuery dataset, we have created a fictitious company called as AdventureWorks. It's a CRM system which has its data warehouse collecting information of various products, categories, and sales orders, as well as for departments and the employee details. It currently holds information about the sales and products and is entire understanding of how the products are being sold by this company. This company wanted to migrate their entire BigQuery cluster to Redshift to alleviate a lot of cost, as we have seen in our use case with Katera, where they wanted to optimize their cost, also improve their efficiency by adopting Redshift. To achieve that, the fastest way is to use something called as Glue BigQuery connector. So here we have used Glue BigQuery connector to connect to BigQuery and extract all of these tables from BigQuery and store them on S3 as individual Parquet files. Once we achieve this, we can just run this particular Glue job. And as soon as this job is complete, it can extract terabytes or petabytes of data out of BigQuery onto S3. Let's give it a couple of minutes to run. We have already started executing that job, and it is currently in the running status. This is currently connecting to BigQuery and extracting all the tables onto S3. As we can see, this job is now successfully executed. So as soon as this job is finished, we can see the data being extracted from BigQuery and is available as Parquet files onto S3. As soon as these files are available on S3, our tool automatically detects the schema of these files, which has been extracted from BigQuery, and starts converting them into Redshift table. So we have created a quick and easy QuickSight dashboard to understand what's going on with the files as soon as those are available onto S3. So here in the QuickSight dashboard, we can see each table which is available in S3, which has been exported from BigQuery, has an associated Redshift table with the timestamp of when it was created and when it has finished processing, and what was the command used to ingest and create that particular table with the schema. Now, let me remind you, we just didn't create the table out of the file which is being exported. The files which are exported, we also converted the data types. We made sure the data types which have been exported out of BigQuery and written into Parquet files are then adapted to Redshift. We have made sure every data type which Redshift support is been transformed from what BigQuery supports. So we inherently take care of the data types and the table schema conversion while exporting the data from BigQuery onto S3, and then use our automation to ingest this data onto the Redshift. Now let's go ahead and see what we can see in the Redshift cluster. As soon as this process is finished, we can see all the tables which are available in BigQuery are now available in the Redshift. So let me just quickly write a query to see if the data is available in Redshift. As you can see, the department table, which has been exported from BigQuery, is now available in Redshift. We have used this automation to migrate from few terabytes to up to 2 petabytes of BigQuery clusters to Redshift, which has helped customers elevate a lot of their cost of using BigQuery and adopt Redshift and Redshift serverless. With this, I want to also demonstrate what do we do with the stored procedures and functions of BigQuery. The blade bridge converter we leverage has two powerful capabilities within the stack. The first is the ability for users to group coding patterns found in BigQuery stored procedures and functions into batches. The second is the common metadata layer, which can convert those batches of similar code to Amazon Redshift stored procedures and functions. The batched coding patterns are run through the converter tested against the target Redshift cluster. The error-free code and the code that came back with errors both get logged. This helps us zero in on the code that isn't converting while the converter discovers patterns in the code. With those errors, we again run the errored batch through the converter, so the converter is a cyclical development interaction of batching and converting and isolating conversion errors. This interactive cycle continues until the conversion is complete. However, unlike manual effort, each batch conversion simultaneously migrates hundreds and thousands of code patterns. This process maintains surgical precision required to migrate large, complex BigQuery clusters to Redshift, while enabling massive acceleration.
Thank you, Bal, for talking about your BigQuery migration practice. Summarizing, if you are thinking about migrating off your legacy or cloud data warehouses, you can leverage numerous AWS programs and capabilities of Redshift to save you time and money. Throughout your migration journey, AWS teams and partners like Mactorus are available to help, ensuring you are following best practices. Starting with understanding your data strategy and designing a scalable, future-proof architecture, we ensure you'll be able to democratize all your data securely amongst your organization to gain a competitive advantage. This will be carried out at scale at the best price performance. If you like to dive deeper into migrations, you can review the migration blog and work with us to migrate your workloads. For more information about Redshift and take it for a spin, go to aws.com/redshift and get started. To reach out to Mactorus, please use the link shown. Thank you for watching, folks. Have a nice day.